We have worked in great detail on binary, octal and hexadecimal. I would just want to show you a few examples of how we extend the same techniques into working in any base. The main thing to bear in mind is that in, say, base 3, we're using digits from 0, 1 and 2, so digits up to 3. If it's base 5, 0, 1, 2, 4, base 60, up to 59 and so on. That means that when we are converting from decimal to any base, say base 3, we keep dividing over and over again by 3 and taking note of the remainders. For the fractional part, we will multiply by 3 over and over again and take note of the integer part. And that's how we extend that algorithm to any base. With operations, you'll see that it's very similar. I'll stop talking and I'll show you some examples. Say we have 1201 in base 3. What is this number in decimal? Well, base 3 is going to use place values that are powers of 3, starting from 1. So we'll write those up as a reminder. I have 1, 3, 3 squared, which is 9, and 3 cubed, which is 27. That means we go straight to the expanded form, which is 1 the digit times the 27, plus 2 the digit times the place value 9, plus 0 times the place value 3, plus 1 times the place value 1. And that was a number in ternary, base 3, because the digits were 1, 2, 0, 1. There were no digits 3 or greater. Now we have the expanded form, we just do the calculation and get on with it. So we've got 27 plus 18 plus 1, that makes 30, 40, 46. And so 1201 in ternary is 46 in decimal. Let's look at changing from decimal to base 5. Let's do 45.2. 45.2. I'm allowed to say 45 because it's decimal. And we want to write this into base 5. This is the division algorithm. Well, kind of. It is the division algorithm for the integer part, for the 45, and it's going to be the multiplication by 5 algorithm for the 0.2. So let's do it separately. 45, we're going to divide by 5, because it's base 5, and that is 9 remainder 0, and then 9 divided by 5, it's 1 remainder 4, and then 1 divided by 5 is 0 remainder 1. That gives me that the digits for 45 in decimal is written as, remember the first remainder is the left remainder is the rightmost digit. So the 1 is going to be the leftmost, so 140 in base 5. Now let's do the fractional part. So 0.2 in decimal. We're going to multiply that by 5. 0.2 times 5 is 1. 1 is the whole part, so that's going to be the first digit. We take away the 1, we have 0, and so we stop. So this is fractional part is 0, so we stop. And that means that 0.2 is going to be written as 0.1 in base 5, which is okay, because 0.2 is a fifth, and 1/5 is the first fractional place value for base 5. So putting it all together, 45.2 is 140.1 in base 5. So let's look at an example of addition. Let's do addition in base 11. 7.6 add 0.6 in base 11. we're going to stack the numbers one on top of the other, do the addition. 6 plus 6 is 12. 12 is one more than our base, so 12 in base 11. So 12 in base 11 is going to be 111 plus 1. Okay, so it's going to be 1, 1. That means I put a 1 here, the units 1, and this other one for the 11 place value is going to go there on top. And I've got 1 plus 7 plus 0. That makes it 8. 8 is still less than 11, so it's a number we're allowed to use. And there we go. The result of this sum is 7.6 plus 0.6 in base 11 is 8.1 in base 11. I'm going to do subtraction now in base 5. 2.3 take away 1.4, and that's base 5. Stack the numbers one on top of the other, place values aligned. We're going to subtract. And now we have column by column, we got 3 take away 4. Too small, we're going to have to borrow. Now, what we're going to borrow? We have a 2. We're going to split that. That's a 1 plus a 1. We're going to lend it to the 3. So I've got a 1, 3 over there. And now I have that 1, 3, which is a 1, 3 in base 5. So it's a 1, 3 in base 5. What is that? 1, 3 in base 5 is 5 plus 3, which is 8. So really I'm doing 8 take away 4, which is 4. And now the next column, I've got 1 take away 1, which is 0. And so the result is 0.4 in base 5. Does that work? We can always check. Let's add them up. If we do 1.4 add 0.4, what do we get? 4 plus 4 is 8, but 8 in base 5 is going to have to be written using the help of 5 plus 3. So 8 is 5 plus 3 like we did earlier, and that means it's going to be a 1 on the place value of 5 and a 3 on the place value of 1. So I write the 3 here and the 1 on top, and now I add the 1 with the 1, which is a 2. And that's correct. Now let's look at one more example, multiplication in base 7. 1, 2, base 7 times 6, 0, base 7. Let's do it. 1, 2, 6, 0. 0 times 2 is 0. 0 times 1 is 0. And now 6 times 2 is 12. 12, but 12, what is that in base 7? Well, let's split the 12 as a 7 plus something. So it is 7 plus 5. That makes it 1, 5 in base 7. So we do 5 here and the other one over there. And now 6 times 1 is 6. Put it there. And let's add everything up. Column by column, 0, 5, and then 1 plus 6 is 7. But 7 in base 7 is 1, 0. So 1, 0. I'll just note it down here on the side. 7 is written as 1, 0 in base 7. So that's what we did over here. And therefore the result is 1050 in base 7. And with these examples, and with a little bit of revision of what we've done on all the other bases, you should be able to perform base translation and operations in any number base.